All right, welcome back again, guys. So this section is on kinetic energy, and kinetic energy is all about movement. So potential energy is about position, so the height of an object, the mass of an object, and the gravitational influence to determine how much energy is in that object. While kinetic energy deals with mass, so we're still dealing with that, but now we're taking into consideration how fast something's going. So for kinetic energy, our formula is 1/2 mass times velocity squared, and that's going to be our answer still in joules. And our formula, broken down right here, 1/2 of mass, as in kilograms, times meters per second squared. So the one thing you got to make sure that you do is always square that. For this section, what we're going to do is just calculate kinetic energy in one direction. We're not going to solve for any unknowns yet, because I want to teach you guys and spend a little more time about breaking the problems apart and tackling those sections to make sure we can solve for either the mass of an object, or the velocity of the object, or how many joules of that object. So to start with, we're just going to calculate joules. So let me get rid of this, and I'll put up a couple practice problems. So the first one I've got is I have a mass of 3 kilograms. So I got a small bowling ball, let's say, and I'm rolling it down the alley at 2 meters per second. And I want to know its kinetic energy. Oops. Question mark. So my formula, remember, 1/2 mass times velocity squared. So I'm going to do it this way. This way works really easy in the calculator. So you don't have to do the 1/2 of something. So 0.5 times 3 times 2. But remember, I'm squaring it. So I'm going to square it on the outside. And that will give me an answer of 6 joules. So number 2, let's say we're talking about something larger. So let's say a truck. So my truck has a mass of 2,900 kilograms. So that's a fairly large vehicle. And it's moving down the road at 55 meters per second. And don't worry, these are also on the worksheet. So as you guys are looking through this, you'll see how I do this. And E of K, again, I'm not sure of. So the first thing I'm going to do, I'm going to set up my problem like before. So I'm going to go 0.5 times 2,900 times 55 squared. Okay. So if I punch it in my calculator just like so, my answer will come out to 4,386,000. I'll fix my 4 there. I'm notorious for bad 4s. And 250 joules. Okay. Now, if you guys look at these problems and you work through them, one of the things that you're going to realize really quickly is that velocity, since it's squared, has a lot to do in these equations. The amount of potential energy and kinetic energy that an individual or a system has can sometimes be equal. And what I mean by that is, for potential energy, I could jump from a lower height and have the same potential energy as a student who is less massive than me, who has to jump from a higher height. So if I was doing a cannonball into a pool and we wanted to calculate how much energy would be equal, the person who's a lighter fare, who has less mass, would have to be at a higher position to have the same amount of energy. Just in the same way that me running, and let's say as I'm a football player, to have more kinetic energy, I'm going to have a greater mass, and I might have slightly less velocity, but sometimes my greater mass will outcompete the amount of energy in this system. So I hope this is a good start to explanation. I'm not good at doing things through computers, I guess, yet, or doing a model like this. So I hope it helps you guys. Please feel free to reach out for help if you're needed. I'll be around, and I look forward to working with you guys some more. Thank you.